So I'm sorry I can't be with you, but a very quick introduction to the new primary computing programme of study. I want to start by talking about Froebel blocks, these sort of building blocks we give still to very young children during early stages of their development, and I wonder why we do that. It's not, I don't think, because we want them to become architects or construction workers when they grow up. But it's because playing with things like this teaches a small child about how the world works. They learn that gravity works downwards, that number doesn't change, that some structures are more stable than other structures. It's also, of course, a great way of expressing their own creativity, and the structures which they produce will be unique and will be their own way of interpreting, of creating things with these blocks. Similarly, I would argue what we're doing with computers in the new primary curriculum. Look back at what Jim Rose came up with back in 2009 when asked to review the curriculum, and you see how things have moved on in the last 5 years. Nothing wrong with what he suggested, but how come he failed to mention creativity here as something which is essential to our understanding of how ICT was used in primary school? And yes, he does focus, or he does mention understanding, but the focus is very much on using technological tools, using things to get things done. Okay. Look at what we have now, though, in the preamble to the new programme study, and you see such a significant move on. High-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. That's our ambition. This isn't about learning to program computers. This is about understanding the world and changing the world. It's about thinking of problems in such a way that a computer can help us solve them, and it's about expressing our own creativity, or children's own creativity. The structure of the programme of study reflects but doesn't necessarily highlight this three-part structure to it. You have computer science, you have information technology, and you have digital literacy, all in there, all to some extent intertwined. Computer science is the foundations of the discipline, the fundamental principles on which computation, on which programming is based. It's also, of course, where you get to do all of that lovely lab work of coding, of programming. We have the applications of this to real-world problems, to expressions of creativity and getting things done, using software that other people have made, using the web as a service for that. And then we have the implications for us as individuals, and indeed for us as a society, of the impact of this technology on people's lives. If you wish, think of it as the science, as the engineering, as the sociology. So now getting into the nitty-gritty detail, this is what we have on the Key Stage 1 programme of study. Now my suspicion is that much of this you're doing already. There are new elements here, and if I put a highlighter on those, you'll see what we have. So it's not the programming. That's always been on the national curriculum. What's new is the thinking about that, getting children to think of algorithms, yes, to use the word algorithm, which simply means a sequence of steps, a set of instructions, a set of rules to get something done. Programming, if you will, is a two-step process. We start by thinking of how to solve the problem, the algorithm, and then we have the implementation of that as code on a particular device. We also have here a focus on using logical reasoning. And eventually, of course, we get e-safety as a requirement of the national curriculum. Key Stage 2, lots and lots of text there. I draw your attention to bullet point 6, which is a whole train wreck of drafting in its own right. But again, taking my highlighter pen out, these, I think, are the bits which we haven't necessarily been covering under the old programme of study. Decomposition of problems into smaller parts. That's not just something you use in computing. Doing a research project, planning how to solve a maths problem involves breaking it down into smaller parts. Specific requirements about programming. Again, a reference to logical reasoning. Again, a reference to algorithms. It's the computational thinking that's new, not so much the programming bit. Yes, there are other expectations in there about computer networks and about how search engines such as Google, such as Bing, work. Also notice that emphasis on data, and again we have an e-safety requirement. Just to reiterate, it's not about coding. There's much more to the use of technology in school than computing per se. There's much more to computing than computer science, which is just one aspect of the new programme of study. And computer science itself includes much more than coding. Yes, that's part of it. That's the fun bit. That's the lab work. there's more to it than that. And indeed, there's more to coding than Scratch. Lovely as Scratch is, it would certainly be my go-to toolkit there. So down in Key Stage 1, we have understand what algorithms are, how they're implemented as programs on digital devices. None of that requires you to use technology more sophisticated than the dear old Bebot. Although, of course, by the end of Key Stage 1, you probably would be wanting to make some progress onto something else, such as Scratch, which is a lovely graphical programming toolkit. Notice that a simple drill and practice maths program such as this, where the fish asks us a multiplication question and we have to answer with either the right or the wrong answer, covers the programming requirements of the program study. Sequence, we have a sequence of instructions, one after the other here. Selection, we do one thing if it's right, another if it's wrong. And repetition, we go round this loop 10 times. We're keeping track of the score and we're keeping track of these two random numbers. They're my variables in this. Input and output, okay, it's displayed on screen and we type our answer at the keyboard. Understanding how the internet works is ambitious. We're talking about a network of computers all connected together, passing packets of information by the most efficient route possible. And that provides multiple services, email and Skype, and of course the World Wide Web. Not enough in there about how the web works. Understanding how search works, Google place results into order dependent on a huge number of factors, 200 odd signals that they pay attention to. The advert at the top is chosen because of what they know about me. They're hoping that I will click on this so that money changes hands. But the top results here are ones which are determined by the number and quality of inbound links. So is this a high expectation? Well, Key Stage 1, I think this is a reasonable thing. I really do. This is what Ofsted said back in 2011 about the old programme study. In Key Stage 1, pupils were able to learn programming through devising testing sequences of instructions for floor robots. They saw less of that in Key Stage 2. Not enough opportunities to develop their understanding of programming, their data logging and their data handling. And sometimes those weaknesses arose because of teachers' limited skills and understanding. This is not insurmountable. There's plenty of time to learn this subject content, to get to grips with this, to have some fun doing so. What are the challenges ahead? How many schools will genuinely take this up? If you're an academy, free school, independent school, this is entirely optional. I think that would be a shame not to buy into this, I really do. Teacher training, I think we're doing a jolly good job at the moment. There are a number of continuing professional development initiatives out there. You're starting to see commercial and indeed other schemes of work emerging. Assessment is a really interesting issue. Think badges, go granular. We're starting to see lots and lots of resources from our friends at CAS. One of the issues that worries me particularly is how we teach that. I think the flaws with the old ICT lessons were more than just the curriculum content. That the way this is taught in a way which encourages the development of thought and the development of creativity is something which I think we need to get right. I've probably spent too long talking to you now, but I will put up my contact details on the screen if you do want to get in touch. And as I say, I'm really sorry that I'm not there in person. Thank you very much.